I want to hit home today about is that all of these graphs that we're teaching, they're based on the exact same format. And that is that there are 4 places to find information. You can find information on the y-axis. Okay? You can find information because it's whoa, where is it? It's delayed is what's going on. Oh, and it's really pale. Okay, so hang on. You can find information on the y-axis. You can find information on the x-axis.
Oh, my screen time now.
You can find information on the slope. And you can find 1, 2, 3, 4. And you can find information on the area under the curve. Every graph. Now the thing is, so far we have learned x versus t, okay, graphs. And on that one we know that we can get slope as our velocity. If I take that off and I turn this into a velocity graph, well, my slope gives me something information, tells me its acceleration, and the area tells me something. In a couple of months, we're going to be doing work and time, and that's going to be something. And we'll do, what else are we going to do with time? We're probably going to do force and time, okay? And each time we change that variable that's happening on there, it's kind of like, okay, position, velocity, new meaning. All right, force, new meaning, okay? You're changing your lenses. You're changing how you're looking at it. The metaphor, you were missing the metaphor. But the point is that each time you look at it, you're finding information the same 4 locations. Y-axis, x-axis, slope, and area. Okay? Area. So keep that in mind. Whenever you're, like this is, it's going to be super, you guys are going to automatically know exactly where to go when you're doing this down the line. For now, it's our first time really systematically getting information, so it's a bit tough. Now, here's the information that I want to show you that kind of works with this. Go ahead, you're going to need to draw 3. Okay, we want 3 graphs.
Wait, on this paper or different?
Yep. No, this is notes.
Oh, we're taking notes. Oh,
yes. Okay.
So there's 3 graphs?
3 graphs. Okay. And what we're going to look at is how they change we're going to look at the pattern of the change. Okay, we're going to look at the pattern of the change. First graph is position. Second graph is velocity. Third graph is time. And we are specifically looking at them. Thank you.
Yeah, I was gonna say.
And acceleration, typo. All right, and we are specifically looking at them in this order. Okay? We're going to, on this conversation, we're talking about going from one to the other using slope. Okay? Next week, we'll talk about going from one to the other using area. That'll be the other way. But for this, so on a position graph, we've seen 3 types of lines. Curved line, angled line, and a little bit long, and flat line. So that's not really flat. You fix that. Okay? Kind of flat. All right, let's talk about what this stuff means. So first off, on the first segment, this is a curved line. What's happening in this? It's accelerating. Our velocity is increasing, and our velocity is increasing because the slope is. This is, what kind of a graph is this? Power graph. Remember, what is the graph relationship? It's a power graph, right? So position is changing. Our relationship is y versus x squared. So our position is changing. And when our position changes, that means that our slope changes. And what's the slope of a position graph? Velocity. So our velocity changes. Okay. And what's it called when velocity changes? over time. Velocity changes over time.
Instantaneous?
Acceleration. That means that there is acceleration. Okay, specifically our acceleration is constant. Okay? All right, yes, I will reread. We have y is proportional to x squared. All right? Our position is changing. If our position is changing this way, our slope is changing. If our slope changes, that means our velocity is changing. And if our velocity changes, that gives us acceleration. Now we're going to look at those same pieces again, but we're going to look at them, actually we're going to see what happens next. In this one, it is, our delta x is changing here. What's the relationship on this one? Or the proportionality? Yeah, this was the easy one, right? Y is proportional to x. Okay, so on this one, our slope is not changing. It's a straight line, right? So our slope is constant. Okay, and the slope of a position graph gives us velocity. So if our slope is constant, then so is our speed. And if our velocity is constant, i.e. our velocity is not changing, do we have an acceleration? Nope. Our acceleration is equal to 0. Okay, and we'll do one more color. All right, now here's this last bit. This one is our delta x is constant. All right, we didn't pay much attention to it because we didn't use it that much. That means y is proportional to the constant, or rather y equals a constant. Okay, and if our position doesn't change, then what is our slope? And if our slope is 0, what's our velocity? And if our velocity is 0, what's our acceleration?
0.
All right, see a trend? Okay. So now we're going to take this one and we're going to say, how does this move when we take the slope from here and put it here? Okay? So that the curved line, all right, it's changing, but it's changing at a constant rate. I.e., let's say the acceleration was 3 meters per second squared. That would be, here's 3, and then in the second, here's 6. All right, here's 9. All right, and then see how it gets steep. It's getting bigger and bigger each time. All right, so the rate of change of that velocity, the rate of change of slope is constant, which means it looks like on this side, that curved line becomes a straight line. Our straight line, all right, if it's got a constant velocity looks like a flat line. 0 velocity, I'm going to change some lines here. 0 velocity is going to look like I just need big here.
Oh boy.
Okay. 0 velocity looks like a flat line. Okay. So let's fill in the information. So in this case, we know that our velocity, our delta V is changing. And I knew I needed to give myself more room. Okay. And on this graph, anytime you have a straight line, it's y is proportional to x. Okay. So if our velocity changes, that means our slope here is constant. And what is the slope of a velocity graph? Slope of velocity, when velocity changes, we get acceleration. So our velocity is changing, all right? Our slope is constant, and so is our acceleration. Yes, it is. Now the next bit, I should have drawn this one a bit bigger. Hopefully you'll work our way around it. So in this case, our velocity is 0, isn't it? I'm sorry, said that backwards. Our velocity is constant. So y equals a constant. So velocity is constant, so our slope is 0. And if our slope is 0, what's our acceleration?
0.
Okay. All right. Now let's look at this last piece.
Lowercase a.
Yeah, lowercase for a for acceleration. Big uppercase is area. Yeah. Okay, so this one, this last piece is if your, what color? Pink. If velocity equals 0, the slope equals 0, and acceleration equals 0. Okay. So what is that first line going to look like on the acceleration graph?
No, wait, the first.
Yeah, the first line segment of the acceleration graph is going to look like what?
A straight line.
Straight flat line, right? So that means it's going to look like this. Whoops, wrong line. We're going to have this line. Okay? And what does a flat line look like on the next graph when you take the slope of it?
Go all the way down.
It's going to be a 0, isn't it? And then the next bit's going to be 0 as well. Okay, let me give them the dot part. So that'll connect here. And then I just want to deliberately, I'm kind of breaking this off to talk to you guys about it. So when our acceleration is constant, that's what we got. Acceleration is constant. And then what's our next one? Okay. Actually, what is it?
Wait, which one? The slope?
Our acceleration is constant, and basically our slope is 0. This one, acceleration equals 0, slope equals 0. Acceleration equals 0, slope equals 0. As an FYI, not that we're ever going to use it, but just because it's cool information, you guys ever been in a car and the car is speeding up, and while it's speeding up, you kind of do this because like maybe there's a bit of a misfire or something in there? All right,
Like
it's
a
literally a jerk. That is what it's called. That is the physical quantity. You go from position to velocity to acceleration to jerks. We will never use it, but that's what it is. So like this right here, it was an acceleration that's changing at the constant rate. So if your acceleration changes at a if your acceleration has a changing rate, that's called a jerk.
When you're facing the misfire.
Yeah.
No, me too.
No, yeah, I know. I have a car that kind of does that because it needs some fuel line issues. But anyway, that's what I wanted to show you. It's a 17-year-old car.
Oh, yeah, it's a 2.
Yeah.
Yeah.
All right. So that's really what I wanted to show you. I wanted to show you that relationship and how things move. Okay? Generally speaking, you will only see a curved line here, and you will only see a flat line here. Okay?
You're never going to see a curved line.
You will never see a curved line on there. Once or twice you might see a changing acceleration, but not really. I don't even think can't even remember any particular problems that have that.
And to get from here, you have to go to this one first and then this one?
Mm-hmm. So it's a slope,
And then this
and then it's a slope.
And then this goes.
So much for acceleration. Is there other way you
No problem.
a line going like this? Like a
You
snapshot?
might. There's a small chance you would find that, but we would never go beyond that. All right. Secondary random interesting fact is that Newton. This right here, guys. This is calculus. Okay.